You trip. A steep ledge, loose shale, maybe a root hidden under leaf litter 40,000 years ago. The crack is immediate, not heard, felt, a white snap of sound that travels up through the bone before the pain even registers. There is no hospital 2 miles away. No ambulance. No X-ray. No surgeon. The nearest thing to a doctor is whoever in your band of 30 people has watched enough injuries to know what to try next. Your leg is broken, and you are completely dependent on what the people around you decide to do in the next 30 seconds. Right now, a hospital can stabilize a complex femur fracture in under 4 hours with titanium rods and a recovery ward. Ancient humans had none of that. So how did they survive broken bones at all? The answer is not what anyone would assume, and it is far more sophisticated, far more human, and far stranger than the standard image of prehistoric people limping until they died. In 1971, anthropologist Eric Trinkhaus began studying a skeleton recovered decades earlier from Shanidar cave in northern Iraq. The remains, belonging to a Neanderthal individual now called Shanidar I, dated to roughly 45,000 years ago. What Trinkhaus documented was extraordinary. This individual had survived a crushing blow to the left side of the skull that likely blinded the left eye, a withered and partially amputated right arm, severe arthritis throughout the body, and a healed fracture of the right leg. The hard number that made this internationally significant, Shanidar I, is estimated to have lived to between 40 and 50 years of age, ancient for a Neanderthal, and biologically impossible without sustained, deliberate care from others. A one-armed, partially blind individual with a healed leg fracture does not forage or hunt alone in the Zagros Mountains. That person survives only because the group decides, collectively, that they are worth keeping alive. Trinkhaus called this evidence of Neanderthal compassion. The bone was the proof. Here's where it gets strange. Everyone assumes that the ancient world was a brutal filter, the injured died, the strong survived, and medicine was something civilization invented. The truth is that healed fractures in ancient skeletons are not rare. They are everywhere. Paleopathologists, scientists who study disease and injury in ancient remains, have found healed bone breaks across virtually every early human population examined, from Homo heidelbergensis specimens 500,000 years old to hunter-gatherer populations from 10,000 years ago. The body, given stillness and time, heals itself. The evidence carved in bone tells a different story than the one most people have been told. But what did they actually do with a break, beyond simply waiting? In 2019, researchers analyzing skeletal remains from a burial site at Sungheir, Russia, dated to approximately 34,000 years ago, documented multiple individuals with healed long bone fractures showing signs of anatomical realignment. That detail matters enormously. A femur left to heal on its own tends to shorten and angle as the bone knits. These femurs had healed straighter than chance would allow, suggesting the limb was physically repositioned and held in place during recovery. Archaeologists estimated at least several weeks of immobility would have been required to produce that alignment. The closest modern analog is splinting, and there is strong ethnographic evidence drawn from observed hunter-gatherer groups in the 20th century that splints made from bark, green wood, and plant fiber were likely in use across dozens of prehistoric cultures long before any written record. The Sungheir individuals did not just survive. Someone held them still, fed them, and waited. The biology of bone repair is also not passive. When a fracture occurs, the body launches an inflammatory cascade within hours. Blood clots form, stem cells migrate to the site, and within days, a soft callus of fibrous tissue bridges the gap. Over 6 to 8 weeks, that callus mineralizes into woven bone. Over months, the body reshapes that woven bone into lamellar bone, the dense, organized tissue of a fully healed fracture that looks, under a microscope, almost identical to original bone. The skeleton does not wait for permission. It begins immediately. What ancient humans had to provide was not a cure. It was protection from further damage long enough for the system to run. So what happened when the break was severe enough that the body couldn't compensate alone? This is where the archaeological record turns genuinely surprising. In 2007, a team led by archaeologist Fernando Ramirez Rotzi published analysis of a 100,000-year-old Neanderthal jaw fragment from the Bau de l'Aubessier site in southern France, and identified something unexpected alongside the fractures. Evidence that teeth had been used as tools to compensate for a partially disabled arm. The individual had lost the use of one arm entirely. Yet the wear patterns on the front teeth suggested years of continued activity, likely gripping and pulling materials with the mouth to substitute for the missing limb. This person did not die when the arm did. They adapted, probably with assistance, and lived on for years afterward. The jawbone was dated precisely because of its stratigraphic position, within a layer of sediment deposited between two volcanic ash events. The survival was not incidental, it was chosen. There is also the matter of plant medicine, and here the evidence becomes genuinely contested, which makes it more interesting. not less. In 1960, paleoanthropologist Ralph Selecki proposed, based on pollen samples recovered from Shanidar cave, that Neanderthals had deliberately buried their dead with flowers, specifically medicinal plants including ephedra, groundsel, and grape hyacinth, all of which have documented pharmacological properties. The claim ignited decades of debate. A 1999 reanalysis by Jeffrey Sommer suggested the pollen was likely introduced by a burrowing rodent, not intentional placement. The controversy has never been fully resolved, but the plants themselves were present, and the broader ethnobotanical record, from dozens of hunter-gatherer cultures observed in the 20th century, documents routine use of anti-inflammatory plants like willow bark, which contains salicin, the natural precursor to aspirin, for exactly the kind of sustained pain that accompanies a healing fracture. Whether Neanderthals made that specific connection is unproven. That their descendants did, and did so independently across multiple continents, is not. But there is a deeper pattern running underneath all of this, and it reframes the entire question. The most significant technology ancient humans had for healing broken bones was not a plant or a splint. It was social structure. Injury is not the variable that determines survival in the archaeological record. Isolation is. The Shanidar 1 Neanderthal survived because the group absorbed the cost of his dependency. The Sungir individuals survived because someone had the knowledge to realign a fracture and the willingness to spend weeks enforcing stillness in another adult. A 2018 study published in Evolutionary Anthropology by Penny Spikins and colleagues at the University of York examined 80 cases of healed debilitating injuries in prehistoric skeletal remains from across Europe and the Middle East. Their finding, in nearly every case, the injury would have required a recovery period during which the individual was entirely non-productive, unable to hunt, gather, or contribute to group survival. The group fed them anyway. The group protected them anyway. Spikins argued that this pattern constitutes some of the oldest evidence of what humans actually are, not efficient predators, not lone survivors, but creatures whose survival strategy is, at its core, the willingness to carry each other. The average femur fracture today, with surgical intervention, takes 3 to 6 months to heal. Without surgery, but with immobilization, 6 to 9 months. A Paleolithic hunter-gatherer with a broken leg was non-functional for the better part of a year, and yet they survived. Not because they were tougher, because they weren't alone. Think back to that ledge, that snap, that 30 seconds of people deciding what to do. The technology was never the point. The medicine was never primarily the medicine. What ancient humans brought to a broken bone was something that can't be excavated from any dig site. The decision that a person who could not currently contribute was still worth saving. That decision is older than farming, older than cities, older than writing. The real tool was not the splint. The real tool was never leaving.